Hello everyone and welcome back to RV Boost. We have today a quick tutorial on everything you need to know about Python to start creating Python nodes in your Dynamo script. This is the first in a new series of tutorials that we will do here to help you create more powerful Dynamo scripts using almost entirely and only Python nodes. These scripts will run quicker and avoid the need to rely on custom external packages. Now, of course, there are a lot more topics in learning and mastering Python, but the good thing is you don't need to know everything about Python to make the best use of it in Dynamo. That's why I'm showing today all the Python components and commands that I have to use after years of using Dynamo to get many different tasks done. To easily show you these concepts, we will create today the Python version of this node here. So instead of using this out-of-the-box node to create a wall using a curve and a level, I can just make this Python script here, select the curve from the Revit drawing space, pick a level for the base of the wall, and press run. As you can see, the wall has been created, and we will now walk through all the required Python concepts to make this happen. By the way, if you are new to this channel, make sure to subscribe now, because we do tutorials like this every single week. Alright, let's get started. Firstly, for anyone wondering what Python is, it's a programming language, just like some other languages like C#, Visual Basic, and so on. Even Revit itself was created using a programming language called C or .NET. When you use Dynamo, it's just a way of driving the internal .NET code of Revit using this visual programming interface. And as you know already, you can either do that using the nodes that Dynamo provides by default, or you can right-click and choose to create a Python node. This one here. When you double-click on it to open it, you will see this is a script editor. Whatever you type in here will be executed when you press run. So for example, if I change this number from 0 to 99, save changes, see the output, and press run, that is now 99, the value I put in before. Now, of course, you don't want to do something this simple. Usually, people use this Python script here to drive certain things in Revit. For example, to automate repetitive tasks, such as creating views or sheets, or both. To make Python do more exciting things like that, we actually need to give it access to external libraries or references. So, let's see what we have in here already. By default, the out-of-the-box Python node template that you see here right now already include two external libraries, the Python standard one and the design script one. To reference a library like this, you use the import command. That's why you have here import sys for importing the system Python standard library. Think about it as a collection of pre-made commands and methods. Because you have imported it here, later on in the script, you can call methods in this library and run them without having to define them again. In a way, it's similar to when you drop nodes in this Dynamo canvas. By linking nodes together, you are actually reusing different sections of codes that someone has written before and embed it into those nodes for you. It's the same concept here, but only without a visual interface. Anyway, that's the reason why this template starts with importing the standard library, because this one has some useful commands and methods that people use all the time in Python, such as rounding numbers up or down, or checking if a file really exists on your C drive, things like that. The second library, design script, is also imported here, but in a different manner. If I now put a new line between them, we can be clear. So, these three lines here, they are all there to import this design script library. It's a bit longer because the method here is different. As opposed to this system library, which is written in Python, this second library is actually written in a different programming language. That's why in here, we have to first import a transitional library called CLR, that stands for Common Language Runtime. Think about this simply as a way for an application, in our case Dynamo, to run scripts written in a different language as if they were written in Python. So, once we have imported CLR, we can then tell this CLR object to look for a file that contains this design script library we're trying to get. In our case, the file is called proto-geometry. And in here, by doing add reference from CLR, we are just simply saying COR, now look into this file here for a library that I will need later on. If you are curious about where this file is, it's actually under your C program files folder, and then Dynamo, Dynamo Core, version 2 in our case, and then it's here, protogeometry.dll. So all that's happening is this common language runtime has been told to find this file here, and then on the next line we use this information to say look into this file, find the code of this name, and then import everything from it. The star here means everything, and this long group of names is simply the structure that COR should look for in this proto-geometry library file to get to where it stores the program and methods we try to import. Think about this as a folder structure. Similar to that, imagine you have under proto-geometry within the file a folder called Autodesk, and then underneath there you have a subfolder called Design Script, which in turn contains another subfolder called Geometry. So here we're asking COR to go into this file, open the Autodesk folder, open Design Script, open Geometry, and then whatever methods or commands you can see in there, import into this script here for us to later use. That's all there is to it. If you want to learn more in details about certain feature of this Python language, such as the dot notation there, or why this dot here means look up a subcomponent, while this other dot, even though seemingly identical, means executing a command, or maybe why this name has to be in brackets, you can check out my full Python course in this video description. In this video, we're just focusing on the features and commands that will be required for using Python within the context of Dynamo. So let's carry on. The next line is simply to define this in variable. A variable in Python is exactly similar to that in math. It's a thing that holds something that can be useful later on, such as a value or sometimes a list of objects. In our case here, this Python script node has been constructed so that whatever input you bring into it, whereas through a single input port number 0 there, or through multiple ones from 0 to 1 to 2 and so on, all of them will be stored within this variable called in. After that, you are free to carry on executing your custom lines of code in this section here, and then at the end, the result you can put under this other variable called out. So you can see that in and out are perfectly the opposites of one another. In here, you can use just a static value, like in this case 99, or you can use just a variable instead. For example, if I here defined a new variable called name, and give it a value of David, I can then pass that variable to here, save changes, and rerun the script. You can see that now, that's the same name I put into that variable. This is also a good time to talk about data types in Python. In our case here, this is a text value, or in Python's term, a string. There are other data types. For example, a boolean is a yes or no value. If I now say false, that's a boolean value. You can notice a small difference. In here, the false text is having a capital F, whereas here, that is a normal F. This is because that's the Python syntax, and that's Dynamo syntax. However, because they are both looking at Boolean values, they can still understand each other. The next data type is integer. For example, I can have an integer of 3. That's passed on there. But if I have something like 3.5, it's no longer an integer because now it's a double value. Double because it has two parts, the integer part and the decimal part, separated by a dot there. So these are the most common data types in Python. You can also define your own data type. That's something that Revit does a lot. For example here, a wall in Revit is a custom data type called wall. Let's try this if I now remove this wall, for example, and put in here a select element node. This one here. I can then select this line and pass that to input number 0. Maybe let's move things here so we have more space to use. If I now edit this script, as I mentioned before, everything going into this Python script is stored within this variable called in. So I can also say line equal in at index 0. Because here I have 3 input ports, that means there are 3 items in this list called in. If I now pass this to the out variable now, that's the same line I have from Revit. It is of a custom data type, as we can prove by getting the type from this object like this. Let's see what it is. You can see the data type here is model curve. So overall, you have in Python different data types, including Boolean, string, integer, double values, and then custom types such as this one here. Now, if you are familiar with at least one other programming language, when I say object, that might ring a bell for you. And indeed, that has to do with object-oriented programming, which is a way to structure programming languages, and Python is one of them. You can look up online on lots and lots of tutorials on how to understand and define object-oriented programming, but here's a quick definition that certainly will work with Dynamo. An object is very similar to a variable in Python. The difference is it has a lot more features. It can have properties and methods. In our case here, this line is an object and the get type is a method. This method essentially looks at the object and extracts its type for us. In our case, model curve. This object can also have properties such as length, and you can see there, I did it as a test, but it says here, this object doesn't have this property or attribute called length. But if it does, then this property will be extracted and shown to us here as a numeric value. Anyway, because it's not working, I can put this back to the method we used previously. And now we have the data type name in here again. With Python and Dynamo, object-oriented programming is really powerful because that's where you have methods that can do useful things for you in Revit. For example, here I can have something like line.offset or line.mirror or line.trim, and I will do something in Revit such as mirroring or trimming a line for you. Anyway, the real question then is how do we know which methods and attributes are there so we can use them? That's easy to find out. Simply go to your web browser and search for Revit API docs. And that's the one there to open. You can see here, this one is the online documentation for the Revit API. So things like what you want to use when you try to offset a line, you can find it here. Even though there are a few tricks you need to know to look them up efficiently. So let's try one. We know now that's an object of the model curve type. Let's type that in here, model curve. And the first result is a class of the object. A class is similar to a family type in Revit. It's a definition of an object. If an object belongs to a class, in this case model curve, it will have all the attributes and methods that class allows. So let's see what a class has now. Here it is. You can expand this here on the left hand side, and you have here properties and methods. Let's see properties. We have here a test to see if the line is a reference line, if it has certain parameters, or if this is a truss curve type. Under methods, we have other ways to make use of this object here. For example, set whether it should be visible or change it from and to a reference line. For the full list of what we can do with this class, you can go to members. And here, that's a much longer list. The first half will be for methods. And if you scroll down past that group, you have properties. One property we can use right now is geometry curve. And as it's stated here, this will obtain the geometry curve of the curve element. Now, certainly when it comes to understanding and using those methods and properties, it will be much easier if you know the kind of object really well in Revit. For example here, I know a line is a line in Revit as an object because it has an element ID I can check out. This one here. However, this is only the ID of the line object. The geometric representation of this line is actually separate. Let me prove it. You can see here, the ID is 3088 and then 59. If I now make the line a bit longer like that, of course it's just created a wall for me again, because I forgot to delete these nodes. Let's take them out. So, the line is now longer. That means the geometric representation has changed. However, if I select the line again and go to check its ID again, that's still the same ID, 308859. What this shows is this model curve object is separate from the geometric object of this element. To create a wall for our examples today, we need to actually go down one level from here and get the geometric object of this line. So how to do that? Let's open back our Revit API documentation and check out this property here. As you can see, it's something that we can get, so I can just copy this text now. Go back to Python. And after the dot, we can paste the same text. That's how we are saying from this line object, obtain the property called geometry curve and return the result in this out variable. If I now save changes, you can see it has an error because the model curve object has no attribute geometry curve. Isn't that strange? I can see that object certainly has these properties, so why is it complaining? This is why. When we obtain the object using this node here for selecting model elements, if I put in here a watch node and see what's coming out, it's a model curve object. Even though you have the same name and the same ID, that's actually not the same object in Revit. This is simply something that Dynamo is using to wrap this Revit object so that it can make sense of the element. In other words, what you see here now is not a Revit object, it's a Dynamo object. To convert it back to a Revit object, we need to unwrap it. And to do that, simply go to here and type in Unwrap Element. Now we want this method to happen on this int0 input. So let me just wrap that as well in brackets. Let's see what happens now. It's saying Unwrap Element is not defined. That means we are lacking some standard libraries. Let's go back in here now and reference the missing library. Now, knowing which one to use will come from experience. For me, I know this is the missing one. Let me copy it into here. So copy it, go here now and paste it in. This is a library for converting geometry between Revit and Dynamo. If I do save changes, it's saying Revit is not defined. What that means is, it cannot understand that it has to get this library from this parent one, but the parent one, we haven't referenced it yet. Not to worry, I also have now the method to do that. And it's here. Just like with Proto Geometry, we have Revit nodes. It's just a file containing the library. If you want to be sure, I'll show you where. We were looking at Dynamo Core, but because this is Dynamo for Revit, we need to go back a few levels and then go to Dynamo Revit version 2, Revit 2019, and in here, that's the one we are referencing now, Revit nodes.dll. With that out of the way, we can then import the group of commands under Revit within this file, and then also import the extensions from a subfolder under Revit called Elements. That will be for use later on. Let's see if that's happy now. Still the same, so actually, you know what, I just realized now, that's just a typo. It has to be unwrap, not unwarp. And now it's working. So, lesson learned, always watch out for typo when you do things in this Python script. Anyway, now it's working. I can see that the geometric object has been obtained successfully from this object there. It is now a line instead of model curve. This line here, it may have a property called length. Yes, it does. So we're on the right track. The next thing I will show that is specific to Python in Dynamo is transactions. Basically, whenever you try to edit something in Revit, either creating new elements or deleting something else, all of that has to happen inside a transaction. It's just a way to tell Revit, from this point, open a mode where things can be changed, and then once we have done that in Dynamo, tell Revit to disable that mode, so then nothing else can be changed until the transaction is open again. That happens automatically in Revit when you go, for example, to here and choose to draw a line. The moment you click on this model line button there, a transaction is opened. You are free then to create objects. And then as soon as you choose to modify or choose to cancel the command, that transaction is then completed and closed. To do the same in Python and Dynamo, we need to bring in a few more libraries. So let me just copy them from here and paste them there. So again, we have another file here for Python to look at. Revit services, I guess going to be down here. Yes, it is Revit services.dll. So in here, we are telling Dynamo and Python to open this file, import the commands under Revit services, and then also import two more specific groups of commands called Document Manager and Transaction Manager. Next step, we need to have a document so Python can know on which Revit model it should open the transaction. This is because Revit can have more than one document open at a time. For example, you can have a project model here, a family there, and then another project model over here. Python needs to know which one this transaction should be opened for. To define the document, we can use this Document Manager object that we just imported. Let me just copy now the line for this purpose. Is here. So from this Document Manager object, we want to get an instance of this object, and then we want to get the current document that is now active in Revit, and then we want to assign this document object to this doc or doc variable. Now it's time for us to open the transaction. Let me just copy the code for that now and paste that under here. So the syntax can be a bit strange if you are new to Python, but essentially we are creating this object called transaction by this method called also transaction. This method requires two variables to work. Firstly, the document that we just obtained up there, and the second variable it requires is the name of the transaction. Let's try this. I can rename this to create wall. That means once a transaction has been done, you will see under this undo menu the same name, in this case dyn create wall. As you can tell, I have a few happened previously already, so there's one there, dyn, another one here, and a third one there. This line is for creating this wall, but for now let's comment it out so we can make sure only the transaction part is running and clear. To comment out a line in Python, we of course can use the hash key, just like this. I can now save changes, and there's an error. Let's see. Transaction is not defined. Now, you may have seen the pattern now. That means some libraries is missing. And in our case here, we need to reference the Revit API library as well. Let me just copy quickly the code for this and paste it here. So we need to look at the Revit API.dll file, import the group of commands called Autodesk. Underneath that commands group, under Revit, under DB, import everything. And also under DB architecture, we also want to get everything, all the commands and methods under that location. With that done, I can try this one more time. And you can see now that has completed. It, however, hasn't shown up there yet, because Python and Dynamo is clever enough to say, if a transaction doesn't have anything underneath to execute, then it shouldn't be registered in the document anyway. So let's try this now. Essentially, the task for this transaction to do is this. For the wall class, which is underneath Revit DB architecture, run the create method. This method you can of course find in the Revit API. So if I now type in here wall, we can look up wall class, expand this, go to members, and there'll be one here for create. Actually, there are more than one. You have here 1, 2, 3, 4, 5. 5 different ways to create a wall. The one we are using this time is this, the second method. So as it shows here clearly, we need to run the create command on the wall class, and this command requires 4 different parameters to run. Firstly, the document, we have this already. Then the geometric curve from the line. Then the element ID of the level. and then the Boolean value to say whether this wall here that's being created should be a structural one or not. That's easy to specify. So we have DOC already. GeoCurve is a new variable we need to use now. And it's actually something we have down here already. So it's just now the matter of making this official. I can now do GeoCurve equal line dot geometric or geometry curve. Essentially the same thing we have down here. Next thing to specify is this level ID variable. So level ID equal level dot ID. Again, this is something we will see and you can find in the Revit API. If I type it here now, level, we can go to the class. Under this class is members. There should be one properties called ID. This one here. The question now is, have we defined this level object? No, we haven't. But luckily, that's easy enough to do. I can just right click here now, choose level. And here, Dynamo has already an easy way for me to select one level from the Revit file. I can now supply this to maybe here, input number 1. Number 2 I can remove now, we don't need that anymore. And see how I can make use of this new information. So, similar to the line coming from unwrapping input number 0, I can now copy this one down. Give it a bit more space. And change this to level. Because that's the parameter or variable I want to use here. From input 0, let's change to input 1. So, here's what's happening. We're obtaining the level object from this dropdown in Dynamo. But because that's the Dynamo object, we have to unwrap it to obtain the level object in the Revit API. This object here, we know it has a property called ID. So we are calling that to get this ID value and assign that to this new variable called level ID. We can then use that straight away down here. The fourth input is whether the wall should be a structural one or not. I'm putting here true, but you can also say false. Just remember to have the first letter capitalized. Next step, we can look at this line here. Essentially, it's for starting this transaction. So this object has this method called start. As soon as this line is run, the document here is open for editing. That's when we will put in here this new wall using this command. And when that's done, we can call the transaction object again with the method commit. This will save whatever modification happening up there into the Revit file and then close the transaction. We can also copy this new wall parameter down to the out variable. So when this one is run successfully, we can see the wall here. Let's now do save changes. And straight away you will see that wall is there created for us already. Also, as promised, if you now go to undo, you have here now dyn create wall, which is the transaction name that we have defined right there. So far so good. Let's now look at a few more advanced Python methods that I have used for the last few years when working with Dynamo. Now firstly, we have here one wall created, that's fine. But what if we want to have multiple ones? Let's save this one here for now. And let's do a new node to select multiple lines. Select model elements, that's the one there. We're gonna do select and get these 3 lines. I can see there are 3 of them now because I have 3 IDs reported here. Let's now use this one as input number 0. And straight away you will see there's an error there because now the Python script is trying to call this property from a list of objects. Previously it was working because this was called on one single object or one single model curve, this one there. But now because we have 3 of them, it needs some modification here for the things to work again. This is the perfect time to mention Python list. Essentially we want to have not one object but 3 of them. So let's do that now. We now know that input number 0 is no longer just a single line, so let's rename this to lines. That is now a list, so instead of calling this method straight away to make the new wall, we need to iterate over this list. Iterate means check each item in the list, do something with it, move on to the next, and only stop when all items have been checked. So to iterate over this list here, we can use a for loop. I can do for line in lines, do something. Again, if you are curious about why we have to get different amounts of indentation here and there, that's also basic Python syntax, so feel free to look it up online. Anyway, for this line here in this list, I want to get the geometry curve, so let's cut this line and paste it down here. Next step, I want to convert this geo curve or geo line to a new wall. So this one can remain unchanged. Now I want to have a way to keep track of results, so let's create here a new list. In Python, you can just create an empty list like this, maybe results equal square brackets. That means a list that is empty. If I want to have something like a list with a number 1 in it, I can do this, or if I can do 3 numbers, that's a way as well. But for now, let's do only an empty list, because here I can do results dot append new wall. Doing this means when it gets to this line, the wall is created, and then immediately the wall will be appended or added to this empty list. When the for loop returns to process the second line, it will create a second wall to this list here, and the third one will go the same way. At the end, we should have in here 3 new walls. Let's check it out. So I will copy this and assign that to the out variable. We can now run the script. And suddenly enough, you have now 3 walls, both in Dynamo and in Revit. Keep in mind, however, not everything created has to go into a list of results. For example here, I can just disregard this wall here. It will still be created, but I don't want to see it in the result. I actually want to see the line's length. So I can do line dot length. Now when I run this, I get an error because the model line is not the same as the geometry line. So I actually have to use this parameter instead. Get it to there and do this again. Of course there'll be overlapping walls because I have here 3 already and I'm making 3 new ones. That's fine for now. The key thing is this, I have back 3 different lengths because I have 3 lines. These 3 new walls are still there, I just don't see them in here. Next thing to check is conditional statements in Python. That can come in handy very quickly. So how about this? I have here 3 lines, but I also want to create a wall from them if a line's length is greater than 15. So this second one here should be used. That's easy to do as well. Let's do if geocurve.length is greater than 15. And then if that is true, we can then execute this line and that one. Click Save Changes. New walls created and overlapping, that's fine. But I have here now only 2 items in this result list. That's how I know the condition has worked. Back to Python. Something else you may need to use when working with Python and Dynamo is functions. A function is simply a way to put some lines of code into kind of a closed container. And whenever you want to run those lines of code, you just call the container instead of copying them all over the place. It just helps make your script a bit more concise. That's one benefit. Also, if you want to use recursion, which we will get to in some maybe future lessons, because it's very advanced, function is also the only way to go about it. So, let's say I want to have this line here in a function, because somehow I don't want to copy it over and over again. I can go up to before it is executed and define a function. So define function, let's say make wall. That can be my function name. And the input will be the geocurve. I can then follow this by a colon and start defining what the function should do. In this case, I can just cut this line and paste it here. That means under here, in the for loop, after the conditional statements, I can just call this function. That's a lot shorter than typing out a full line of code in here. We can now do save changes. The function has run and the result is the same. It's just a better way to code, because one of the key principles in coding is that you need to try and avoid repeating yourself. If I run this line here 3, 4, 10 times in multiple places in a long script, I don't want to copy it over and over again. By putting this line in this function, it will be also easier for me to change what the function does, and this will trickle to all of those 10, 15, 20 places that the function is used. That's really efficient. Now, to make you even more confident in using Python in Dynamo, another concept to know about is dictionary. So if I do dictionary, I can make a new one, which is blank, using curly braces, like this. A dictionary is just similar to a list, but instead of having individual items, it is like a real dictionary, where if I want to look up the definition for apple, I will go to the pages for the letter A, look for apple, and then see the value or the text that this key contains. So let's say I want to look up the created walls by their element IDs. I can go here and do this. Dict, then the key, then the value. The value here will be the new wall, and the key will be the new wall ID. Now, before you run this script, it's gonna fail because this new wall here is not defined. I know we have new wall in this function, but it never comes out because this function here doesn't return any value. To make it return the new wall, we can do return and then new wall, as simply as that. That means also here, I need to do new wall equal the result of this function. Let's do save changes. And again, new walls are created. Nothing changed, but only because I haven't put this dictionary here to the output. Let's do that now. Oops, this is the result we don't want to get. Essentially, when you go to create a dictionary and populate it, the key and the value must have some certain requirements satisfied. In our case here, the key should not and cannot be an element ID. That's fine. I can do toString to convert it into a string. And do this again. Here we go. Now we can see this dictionary here has 2 items. The first item is a wall, and if we want to look it up, that's a key to get it. The second item also a wall, but has a different key. So if I know the ID of one of them, I can simply look them up using this key here to get to the object. Okay, so that's just a very quick run-up of the key Python concepts that you need to know to start creating Python script nodes in Dynamo. Of course, there's a lot more to Python than this, but from my years of doing this in Dynamo using Python, 99% of the time, these are the concepts that I need to know to do anything in Revit. To continue your learning journey, do 3 things. Number 1, you can follow the link in the video description to join my full online course on mastering Python nodes in Dynamo for Revit. It goes much deeper into even more practical examples, such as creating, editing, and annotating Revit objects. Number 2, subscribe to this channel because after this, I will continue this video series with practical, real-life experience on how to create Python script nodes to do exciting things in Revit. So, subscribe and turn on the notification bell so you won't miss out. Number 3, once you have done those 2 steps and you are waiting for me to release new videos on this topic, you can also do some homework on your own. Just install some of the popular Dynamo packages such as Archilab, Clockwork, or Springs. Open one of the nodes that I have. For example, here I can do elements, door, rooms. This one seems to get the room information from doors. So if you want to further advance on your Dynamo and Python learning journey, open any nodes from those custom packages, double click to open them. And in here, most of the time you will see that the core logic is contained within a Python script node, like this one here. You can then open the script there to see and understand what they did in here using Python. So, get started with these things, and I'll see you in the next lesson.